Hello friends, welcome to Engineering Funda family. In this video, I will explain Viterbi algorithm with great clarity. Before I start with my explanation, let me tell you the outlines of this video. In this video, first of all, I'll discuss about basics, objective and process of Viterbi algorithm. And at last, I will solve an example based on Viterbi algorithm. So let us start this video with first agenda, that is basics of Viterbi algorithm. See, it is a method of decoding convolutional codes. In my last video, I have discussed about convolutional codes. One should know Viterbi algorithm is used to decode convolutional codes, right? Using trellis decoder, we can decode the received data. So here what we will be doing is we will be using trellis decoder, and using it, we can decode the data. That even I will explain by one example that will give you more clarity. First of all, you need to understand what is the objective of Viterbi algorithm. See, Viterbi algorithm is used to find the best path through the trellis. Here, I'll plot trellis diagram, and in trellis diagram, I'll identify closest path. Closest path means the path which is having minimum Hamming distance. So that even I'll explain by one example. Here we will identify closest path with received data bit sequence. Now let me discuss about process of Viterbi algorithm. Here you need to follow some standard steps. See, in first step, we need to construct trellis encoder. So sometimes trellis encoder may be given to you in the question. If it is not given, then you'll have to use standard convolutional encoder. That I'll show you by example. See, first step is to construct trellis encoder. In second step, we need to draw trellis diagram. In my last video with convolutional codes, I have explained how to identify trellis diagram. That process that even I'll follow over here with example. So in second step, we need to draw trellis diagram. In third step, we need to compare received sequence and compute the path matrix with respect to weight on the trellis. So here what I'll do is I'll be comparing received data sequence with the path with respect to weightage, and here weightage will be Hamming distance, and based on closest path we will identify decoded data. So all four steps that I'll follow with practical example that will give you more clarity. So now let me explain example based on Viterbi algorithm. Now here in example, we need to decode the data using Viterbi algorithm if received bit sequence is 01, 10, 11, 00 and 00. So here we need to decode this data using Viterbi algorithm. See, in first step, I have told you we need to construct trellis encoder. If it is not given, then you can consider this standard trellis encoder. Here in this trellis encoder, we give input to M2, and here M0 and M1 that represents states. One should know, see here this M0 and M1 that is representing states. Means here there will be flip-flop with M0 and M1, and M2 that is current input bit, right? If you observe here, we have two outputs. Output is X1 and X2. If you talk about X1, then this X1 that is addition of M0, M1 and M2. So X1 is M1 plus M2 plus M0, addition of these three bits. And if you talk about X2 output, then X2 is addition of M0 and M2. So here addition of M0 and M2, that is X2. And always remember this addition, that is modulo to addition. Modulo to addition means XOR operation. Now in second step, what we need to do? In second step, we need to draw trellis diagram. See, to draw trellis diagram, you need to identify this table. In this table, we have M0, M1, M2. You can observe where M0 and M1 that represent states. If you talk about current state, then current state that is there with M0, M1. So here let me note down current state that is there with M0 and M1, and next state that is there with M1, M2. Next state that is there with M1, M2. How next state is there with M1, M2? The reason is if you insert bit over here, then bits are getting shifted in this direction, right? So M2 will come at M1 and M1 will come at M0. So next state that is there with M1, M2. So based on M0, M1, M2, there can be in total 8 combinations you can observe from 0, 0, 0 to 1, 1, 1. Now first of all, let me note down current state and next state. See here, with 2 bits, in total 4 combinations are there. So here what I'll do is I'll consider state A with 0, 0, state B with 0, 1, state C with 1, 0, and state D with 1, 1. So current state that is there with M0, M1. So M0, M1, if it is 0, 0, then we will be having state A. Then if we have 0, 1, then we'll be having state B. If it is 1, 0, then we'll be having state C. And if it is 1, 1, then we'll be having state D. Next state that is there with M1, M2. So M1, M2, that will represent next state. So if it is 0, 0, state A will be there, 0, 1, state B will be there, 1, 0, state C will be there, 1, 1, state D will be there. If it is 0, 0, state A, 0, 1, state B, 1, 0, state C, and 1, 1, state D will be there, right? Now, we need to identify X1 and X2, that is output. You can observe X1, that is addition of M0, M1, and M2. So here X1, that is addition of these 3 bits. So 0, 0, 0, that will be 0, 0, 0, 1, that will be 1, 0, 1, 0, 1, 0, 1, 1, 0. If you have odd number of ones, then output will be 0 with modulo 2 addition, means XOR operation. 1, 0, 0, 1, 1, 0, 1, 2 ones are there. So 0, 1, 1, 0, that will be 0. 111, odd number of ones are there, means output is 1. If you talk about X2, then that is addition of M0 plus M2. You can observe M0 plus M2, that is X2. So 0, 0, 0, 0, 1, 1, 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 0, 1, 0, 1, 1, 1, 0. So that is how one can make this table. Now using this table, we will identify trellis diagram. See, second step is to draw trellis diagram. So now let me explain how to identify trellis diagram. See, in trellis diagram, here we need to write state A, state B, state C, and state D. Here I have mentioned dot with state A, B, C, and D. If you observe here received bit sequence, that is 0, 1, 1, 0, 1, 1, 0, 0, 0, 0. So in total 5 combinations are there. The reason is output is X1, X2. So 2-bit combination that you need to consider. So in total 5 combinations are there. So here for 5 combinations, I have repeated state A, state B, state C, and state D with 5 combinations you can observe. Now let me plot trellis diagram. See, in trellis diagram, what we need to do, we need to draw lines over here with respect to input sequence. Here, as if you have input that is 0, then we need to draw solid line, and as if we have input that is logic 1, then we need to draw dash line. That is a rule of trellis diagram. And here in trellis diagram, we need to see how transition is happening from current state to next state with respect to input. So here, first of all, let me consider state A. And with state A, if current state A is there, and if current input is 0, then what will be next state? That will be A. So there will be A to A transition with solid line. Why? The reason is current input is 0. If input is 0, we need to have solid line. And with this solid line, here we need to represent output. You can observe output is 0, 0. So if current state is A, input is 0, then next state will be A, and that will be there for all this transition, right? And here we will be having 0, 0. So let me note it down. Now, if you have current state that is A and input is 1, then next state will be B. So if input is 1, we need to have dash line. So if current state is A, input is 1, next state will be B. So by dash line, I need to have this. And at that time, output will be 1, 1. So here I'm noting 1, 1. And that is what I'll make it for all the combinations. Right. Now, we need to understand one more thing. See, this is about input. Now, one input that is given over here. So now, next time input will be given over here. So if input is given over here with state A, I have already drawn these two lines with input 0 or 1. So now we need to have state B calculation. So with state B, if input is 0, next state will be C. So with state B, if input is 0, next state will be C. So you can observe this is state C, right? And output is 1, 0. So let me note down 1, 0 over here. And that I'll repeat for all other combinations. You can observe that I'm repeating it for all other combinations, right? Now, as if current state is B, input is 1, then next state will be D. So if input is 1, we need to have dash line. So if current state is B, input is 1, next state will be D. So here by dash line, I'll show. And here output will be 0, 1. So here output will be 0, 1. Let me note it over here. So that is what I'll repeat it for all other combinations. Now, see here we have given input. And now we have all other states available. But for state A and state B, I have already drawn this. So we need to draw it for state C now. So if you talk about current state C, input 0, then next state will be A. So if input is 0, then solid line. So current state C, input 0, next state A, right? So here I'll be plotting solid line. And with this solid line, here output is 1, 1. So let me mention output that is 1, 1. And that is what repeating over here for this combination C1, right? So I'm just drawing it. You can observe. Now, as if current state is C, input is 1, next state will be B. So if input is 1, then dash line, current state C, input 1, next state B. So dash line, connect it from C to B. And output is 0, 0. Let me note over here 0, 0. And that is what I'll repeat it for other combination C1. Now, let us talk about state D. See, if current state D, input is 0, next state will be C. If input is 0, in that case, we need to have solid line. Current state D, input is 0, next state C. So solid line, connect over here. And output is 0, 1. So note down 0, 1 over here. So that is what I'll note it for all the combinations, right? Now, if you have current state D, input 1, next state will be D. If input is 1, then we should have dash line. So here, let me note down dash line. And here output is 1, 0. Let me note it as 1, 0 over here. So that is how one can draw trellis diagram. Now this trellis diagram, that is bit compact. So what I'll do is I'll consider same diagram. This is enlarged diagram, right? That is what I have explained how to construct. Now let me consider this diagram so that we can easily understand how to decode data using minimum weightage path. So here, to understand minimum weightage path, first of all, you need to see what is our received data. You can observe our received sequence, that is 01, 10, 11, 00, 00. So let me note it over here. This is what received sequence. Now with this received sequence, we need to identify minimum weightage path. So first of all, here we have state A, state B, state C and state D. If you have received sequence 0, 1, then with this path, output is 0, 0. So difference in between 0, 0 and 0, 1, that is of 1 bit. So here there will be weightage of 1. And if you follow this path, then difference in between 1, 1 and 0, 1, that is of 1 bit only. See, 1 and 1, that is same. Only 1, 0 means there is 1 bit difference. So here also we have weightage of 1. So with this path, we have weightage of 1. With this path, we have weightage of 1. Weightage of 1 means Hamming distance is of 1 bit. Now, here, see, we are receiving 1, 0. So if you follow this path, then you will have to take a difference of 1, 0 and 0, 0. So here we have 1 bit difference in between 0, 0 and 1, 0. So with this path, if you talk about total weightage, then previous weightage plus current weightage, that will be 2. And if you follow this path, then with this path, if you identify difference 1, 1 and 1, 0, then 1 bit difference is there. Previous weightage is 1. Current weightage is 1. So over here, there will be weightage of 2 by this path. Now, here if you talk about this node, then that is connected over here. So with this path, here if you take a difference of 1, 0 with 1, 0, then there is 0 difference. 1, 0 and 1, 0 both are same. So previous weightage is 1, current weightage is 0. So over here weightage is 1. Now by this path, if you take a difference in between 0, 1 and 1, 0, so here 2 bit difference is there. 2 bit difference means weightage is 2, previous weightage is 1, current weightage is 2. So over here weightage will be 3. So that is how weightage explains minimum Hamming distance. Now let us identify weightage at this node. So if you follow this path, then over here received data is 1, 1. Here with this link, output is 0, 0. So 1, 1 and 0, 0 difference is 2. So current 2 and previous 2 means over here there will be 4. But at this node, one more link is connected. You can observe this link, right? So if you talk about this link, then this link that is having 1, 1 and 1, 1 and 1, 1 difference is 0. So 1, 1 and 1, 1 difference is 0. So previous weightage is 1, current weightage is 0 with this link. So over here there should be 1 weightage. So what will happen? We will have to discard this path and we need to write weightage 1. And this weightage 1 that is there with respect to this link, over here weightage is 1, right? So you will have to eliminate higher weightage. The reason is higher weightage is there with higher Hamming distance, right? Similarly, at this node is connected and with this node weightage is 2. So if you follow this path, then here we have 1, 1, here we have 1, 1. So 1, 1 and 1, 1 difference is 0. So weightage over here will be 2. If you follow this path, then here weightage is 1. Here output is 0, 0. Difference with 1, 1 is 2. So with this path, weightage is 2 plus 1, 3. So we don't need to consider this path, right? So now we are eliminating this path. Only this path is available. Likewise, you just calculate for other nodes even. But if you observe, here we have weightage 1. And with this link, we have 0, 0. Over here, data is 0, 0. So if you consider this path, 0, 0 and 0, 0 difference is 0. So current weightage is 0. Previous weightage is 1. So over here, there will be weightage 1. And over here we have received sequence 0 0. With this link we have 0 0. So over here weightage will be 1. So if you identify other weightage, right, then, but obviously that will be higher than 1. The reason is as you go in this direction with other link, there will be higher weightage. So you'll have to ignore all other path, only the path that you need to follow, which is having weightage 1 over here. So let me show you the path. See this path that is having weightage 1 and other path that is having more than 1 weightage. So having distance with this path that is 1, right? So as and when you receive data sequence that is this, then you will be decoding data over here, decoded data that will be 1 1, then 1 0, then again 1 1, then 0 0 0 0, right? So if you observe, here decoded data is this and received data sequence is this. And if you compare these two data, then you'll be observing here there is 1 bit error. There is 1 bit error. But remember, see, having distance is 1 with this path, that is having closest path, right? And this Viterbi algorithm that will not identify error, it will gives you minimum weightage path, and minimum weightage path that can be encoded easily, right? The reason is it is having minimum having distance. So this is what you will have to follow to understand Viterbi algorithm. I hope you have understood this. Always remember, Viterbi algorithm is used to identify closest path which is having minimum having distance. It is not used to detect and correct the error. As and when you decode the data using Viterbi algorithm, at that time we will be having closest path in trellis encoder. Here there can be error, right? But with closest path, there will be faster encoding. So that one can understand based on Viterbi algorithm. I hope you have enjoyed this. Still, if you have any confusion, just place that in comment section. I'll be happy to help you. Thank you so much for watching this video.